right, so we got 1, 2, 3, 4, 5, 6, 7. You'll have like 9 multiple choice questions on Thursday, and 7 of them could be like this. Well, these could be some of the 7. Probably not quite as many of these bless you types, but any one of these could work. All right, they're not numbered, so let's just kind of work with this one here. Sine of arc cotangent of 7x squared thirds. So we start with an angle or a ratio? Start with a ratio. The arc cotangent, which we didn't memorize what the graph of the PVR was, we know that that's going to give us some angle theta. And then we're going to take the sine of that theta, and we're going to end up with a ratio. So we start with the ratio, we end with a ratio. So for this type of problem, you'll just draw a generic reference triangle, and you label the sides based upon the given ratio. Cotangent is what in terms of x, y, and r? X over y, yeah. So we got a 7x squared here and a 3 there. And then by the Pythagorean theorem, if you need to call that r temporarily so you have a placeholder, that's what variables are for. But hopefully at this level, you should be able to just realize that that's going to be the square root of 7x squared quantity squared, which is 49x to the 4th, plus 3 squared is 9. Is that going to equal 7x squared plus 3? No, that was one of those things we had yesterday. We proved it wasn't true, right? We found a counterexample. X squared plus y squared does not equal x plus y. It's one of those super tempting things that people want to do. But because they're added, not multiplied, it doesn't work, right? So that's as good as that one gets. So now that we have all 3 sides, we'll just pull off the indicated ratio, which is the sine ratio, which is y over r. So the answer is 3 over the square root of 49 x to the 4th plus 9. And there would be no reason to rationalize that. Okay, so that would be the answer. All right, any questions on that one? Y'all want to work straight down or you want to work left to right? Left to right, okay. Arc cosine of sine of inverse tangent of 0. So in this case, we have a what? Angle or ratio at 0? Of 0. Ratio. So this one is an actual number, so this one we would just work from the inside out. What is the inverse tangent of 0? 0. You have to know your inverse trig functions, which means you have to know the unit circle. Remember, the graph of inverse tangent is the one graph that you're responsible for memorizing. That's the one that has horizontal asymptotes at negative pi halves and pi halves, and it's monotonically increasing through the origin. It's also 1 to 1. So memorize the graph of arctangent. Now, if this were a short answer, you always, at this point, remember, have to consider your notation as part of the answer. You would have to bring everything down. So bring down the arc cosine, bring down the sine. Now what is sine of 0? Sine of 0 is actually 0 from the unit circle. And now arc cosine of 0, where is cosine equal to 0? Pi halves. Why not 3 pi halves? Not in the PVR. Good. So the answer to this one is pi halves. Questions on that one? Trombley? No? No? All right. Inverse sine of 10 pi 11. So here we have 2 inverse functions composed back to back, and we know better than thinking that they'll just simply undo each other. So if you see an answer choice of 10 pi 11ths, it may or may not be the right answer, but it's not necessarily going to be. 10 pi 11ths lives in which quadrant? Quadrant 2, right? And the reference angle there is what? 1 pi 11ths, right? We're just 1 pi 11ths short of pi. So there's the reference angle. And in this quadrant, quadrant 2, sine is positive or negative? Positive. Is quadrant 2 in the PVR of arc sine? Nope. So what is the other quadrant that we want to get into where sine is positive? Quadrant 1. Oops, that's not a highlighter. There we go. So we need to get into quadrant 1, and so it's going to be the same reference angle, but it's going to be in quadrant 1. So in quadrant 1, the reference angle is also the angle because it's positive and acute. So the answer is pi 11ths. Let's take this one here and just modify it. What if instead of inverse sine of sine, what if that had been inverse cosine of cosine? Would they just cancel now? Yes, because 10 pi 11ths does live in the PVR of arc cosine. So the answer would just be 10 pi 11ths. What if this were inverse tangent of tangent? Now it wouldn't be 10 pi 11ths. Would it be just regular pi 11ths? No, it wouldn't, because in quadrant 2, tangent is actually what? Negative. So what would be the other quadrant where tangent's negative? 4. So we would want to get to quadrant 4 by rotating down by pi 11ths. So then the answer would be negative pi 11ths. Okay. So one little angle, but we can look at it at once. Okay. 3 different answers. Secant of arc sine of square root of 3 halves. Do these have a chance of just undoing each other? Nope, because secant and arc sine. Hey, it's raining outside this window. Dallin, out that window? Yes, no? There we go. It must be raining everywhere then. So this one we're going to draw a little picture, or you could just use the unit circle. Let's do that. You don't have to draw a picture. What is arc sine of square root of 3 halves? I'll give you a hint. Pi something. Thirds. Yeah, pi thirds. So now what's secant of pi thirds? Well, it's the reciprocal of the cosine value at pi thirds, so it is 2. Secant of inverse cotangent of 2/3. 2/3, is that a unit circle ratio? No, so we're not going to be able to find the angle. So in this case, we just draw a picture. Cotangent is x over y, so there's 2 and 3. So kind of like the first one, except we have numbers. So this would be the square root of 2 squared plus 3 squared, which is the square root of 13. Does that simplify? No. So we'll leave it at square root of 13. So now the secant ratio is what we're after. Secant is r over x, so it's the square root of 13 over 2. Questions on that one? And finally, well, we got 2 left. So finally this one, and then finally this one. So finally this one. Tangent of inverse cosine of 1.1. 1.1 is a ratio. Is it a legal cosine ratio? No. So now it breaks, D and E. You can't even take the inverse cosine of that illegal ratio to get an angle, so therefore you can't take the tangent of that angle that doesn't exist. And then finally, this one here. And this is a sine of 11 pi 6, so that's being a unit circle angle. We can actually just work this one out. What is sine of 11 pi 6? Negative 1/2, negative 1/2. And then the inverse cosine of negative 1/2, 2 pi thirds, right? Cosine's PVR is the sun, and it has to be over here. And of course, that's your pi thirds reference angle in quadrant 2, which is 2 pi thirds. All right, so that's like the very first quiz that we took last week. Not everyone made 100, so hopefully now you're doing better on these. Any questions before we move on?
Can you work out the unit circle one, like long ways, like as drawing a picture?
Yeah. No, you can do it. Yeah, if it's a unit circle ratio or a unit circle angle, yeah, feel free to use your unit circle knowledge. But if it's not, you're going to have to either draw a picture, like the 2/3, if it's a ratio, or the fun one is when I give you an angle that's not on the unit circle. Then you got to figure out reference angles. Okay, so very quickly here, let's go to the worksheet for this section, because I want to tell you which ones you are able to do based on where we got in the notes, and which ones you're going to omit. So the worksheet will be due on Thursday, but because we're not going to get to the solving equations part of the notes, you're going to be able to exclude some of the problems from the worksheet. Now, there's plenty of practice on the worksheet for the test. A lot of trigonometric expressions that you're going to be simplifying. So make sure you take the worksheet very, very seriously. Don't just pull up the key online and start copying things down. Copies are real easy to make without you having to make them for me. You got photocopiers for that. Okay. Back in the day, it all had to be done by hand. Monks had to transcribe Bibles by hand. So if that's a skill that you're good at, you're just kind of living in the wrong generation. Sorry. And I'm just trying to buy some time here for the bandwidth to download. Is it raining out that window? Brittany, can you see? Is it raining out that window? No? That's not such a silly question because sometimes it does rain in the hallway. Right. But they're fixing the roof right now. So hopefully by this time next year it'll all be good. Okay. So we got through all of these simplifying trig identities in the notes yesterday, and so we're essentially done with the notes. After the test on Thursday, we will come back and finish those notes, and then you'll come back and finish the questions from this worksheet. So the ones that you are going to be able to omit from worksheet 6.1 is question number 5, because it's solving an equation. And then it takes a while to get to the next ones. I think it's the last 3. Yeah. So question number 16 then, question number 17, and question number 18. So basically omit questions 5, 16, 17, and 18. But every other question on the worksheet you should be able to do. Yeah, we're going to come back after the test, and we're going to learn how to solve equations, and then you'll come back and turn these in. Yeah, so we will get back to it. But we want to focus just on testing through the basic identities and simplifying, just because it does get a little bit more exciting. And so this will give you a chance to maybe make a rock-solid grade on a test before it gets more exciting, more fun, more challenging. Challenges are fun to overcome. Okay, so have y'all tried the worksheet and gotten stuck on any one of these? Since we're here in the worksheet. You're like, oh, Mr. Corpy, I tried number 4 like 10 different ways. I spent like 3 days on it. I just don't see the insight. That no one has one of those stories? Because I can help you. Okay, good. So make sure you give all the rest of these your best effort. Yeah. Number 11C. Combine the fractions, then simplify to a power of a basic trig function. Yeah. It's a good one. So I'm kind of giving you the insight in the instructions, which is going to be later one of the strategies that you're going to have to do on your own. Whenever you want to combine, whenever you need to get a single term, you need to combine 2 terms by getting a common denominator. So what was your question?
Can we work it through? Or
Sure. Yeah, let's just look at it. So what do we need to combine fractions? We need a common denominator. What is the least common denominator or multiple of 1 minus cosine and sine? Times sine, right. When in doubt, if you're not sure what the least common multiple is, a common multiple will always be their product. These are actually coprime variable factors, so their product is the LCM. So this one you're going to have to multiply by 1 minus cosine over 1 minus cosine. And then this one is lacking the sine, so you're going to have to multiply this one by sine over sine. And now your denominator is going to be sine of x times the quantity, 1 minus cosine of x. So you can go straight to the one big fraction. And then you're going to multiply sine times sine, that's sine squared of x. And then here, I'm going to multiply 1 minus cosine times 1 minus cosine. That's 1 minus cosine squared, which because this is a plus sign, we don't have to worry about distributing. But remember how we square 2 terms? Square, multiply double, square. So 1 squared is 1. If you multiply, you get minus cosine x. Double, you get minus 2 cosine x. And when you square negative cosine x, you get positive cosine squared of x. Now that you've done that, without getting slapped in the face, you see 1 plus, or you see 1 there, right? Cosine squared plus sine squared is 1. And then the 1 plus the other 1 that's right there gives us what? 2. So 1 plus 1 is 2. So we have 2 minus 2 cosine of x all over sine of x times 1 minus cosine x. And are we done? It says to a basic trig function. So what can we do next? Yes, it's exactly what we need to do. We need to factor out the 2 from the numerator, and we show that in a step. And then we have a sine of x and a 1 minus cosine of x. And now what happens with the 1 minus cosine x factors? They divide out. And you're left with 2 over sine of x, which I'm going to let you finish the last step. I won't tell you what that's equal to, but it is equal to 2 times something. Okay, so there you go. So the worksheet's due when? Thursday, right, minus those problems that we just did. So I'm going to go ahead and go to the end of the worksheet here. You can put this at the end of your, well, I'm going to put it at the end of the notes, actually. So in the notes, we got through yesterday example 6. And on your free response question on Thursday's test, you'll have 4 like this to simplify. You'll have 2 that are pretty straightforward, and then you'll have 2 that are a little bit more spicy. Okay? And that'll be your free response. So all the rest of this is just solving equations, which we're skipping for now. We will come back to it. So if you want to add a page at the bottom of your notes, we'll just kind of supplement here. So let's start off with an easy one. I'm just going to give you the instructions that are simply to simplify as much as possible. We'll call this number 1. Start you off with an easy one. Cotangent of theta times sine of theta. So the way I'm going to do it, I'll give you 1 minute, that's all, to get as far as you can, and then we'll talk about it. 1 minute. And you can try these at home as well. You don't even have to stop the video. Done? Pretty easy? All right. Who's got a final answer? Cosine of theta? That's about as simple as I think this one can be, yeah. What'd you do, Tyler, to get there? All right, so you wrote cotangent as cosine over sine. And then you just left that as sine? Yeah, and you could put it over 1 if you need to, just to kind of see layers. Some people have a hard time realizing something's in the numerator when it's written on the ground floor. And then, of course, what happens? They don't cancel out. They divide out. They only do that. Yeah. Well, we're learning terminology in this class as well, right? It's a higher goal for you. Things cancel to give you 0. Things divide out to give you 1. Yeah. They're no longer there. We can say that, right? They're gone. All right, so the answer is cosine. Pretty simple little one to start with. Number 2. Marshall has a question. No, I don't want you to do that. Okay, good question. The only thing we did with X, Y, and R, why we did that is because we were trying to prove the fundamental identities. Once we have the fundamental identities as our arsenal, we're going to use those identities to simplify and prove things later on. So now we don't have to go back to the definition in terms of X, Y, and R. It's not technically wrong, but it's kind of looking at the code in the program instead of running the program. We don't really need the genetic DNA anymore because we have the user interface now. That's a lot more user friendly. Okay. Number two. Let's try this one here. Simplify are the instructions. secant squared of beta minus 1 all over tangent of negative beta. 1 minute. Go for it. All right. Who has a simplified answer? Negative tangent of beta? Anyone else get that? Yeah, I think that's about as simple as this one gets. Phipps, what'd you do first? Yeah, you don't want to call them the PIDs. That's fine. It's a Pythagorean identity. It's baby PID number 1. It's equal to what? Tangent squared of beta. Good. And the bottom, we have a negative beta. So that's the same as negative tangent of beta because it's even odd identity. And then one of the tangents divides out, and you're left with negative tangent of beta. And William, there's a lot of teachers on this campus that would have said that they cancel out. So it's learned behavior. It's learned behavior. I've gotten on teachers for using the wrong terminology because it reinforces bad things with students. And then it's hard for me to get students and break those habits when they get here. But it is a higher goal that I have for you. So yeah, negative tangent of beta is good. Okay, let's see. They're kind of getting easy, aren't they? They should be getting easier. How about this one? How about cotangent squared of A minus cosecant squared of A all over tangent squared of A minus secant squared of A. Try that one. Anybody got it? Uno? Yeah, very good. It is 1. William, what'd you do in the numerator? Pythagorean? PIDs?
Cotangent becomes cosecant squared of A. And you leave the second one, and then tangent becomes secant squared of A.
They become minus 1, though, don't they? Right? Cotangent squared is cosecant squared minus 1, and tangent squared is secant squared minus 1. And then the others you left? Yep, so good. That's good. That's a good first step. You could also have replaced cosecant squared and secant squared and written them in terms of cotangent squared and tangent squared. So a lot of different ways to do this. And then, of course, if you really drop the parentheses because they're not needed, it just showed the substitution. Now, what happens to your cosecant squareds? Those cancel.
Yes.
Those cancel. And your secant squareds cancel to give you 0. And you're left with -1 over -1, which, of course, is 1. So that's just one way to do it. You could have just realized that cotangent squared minus cosecant squared is 1 if you modify the Pythagorean identity, and then you end up with just 1 over 1. So a lot of different ways to do that one. So it looked kind of ugly at the beginning, but it simplified down pretty nicely. All right. Yes, question?
So on the test, if we get this and clear out, we put 1 over 1, do you want us to write 1 over 1?
Yes. Yeah, because it would indicate what the numerator becomes and then what the denominator becomes. Yeah. So if you did that, you would have to show 1 over 1 and then 1. Absolutely. Yeah, good. That's good. There's a lot of different paths to the right answer. You just have to find one. Here's an interesting one. This one doesn't necessarily simplify down to anything beautiful, but I want you to write in terms of sine of theta, the following. Put the whole thing in terms of sine of theta and simplify as well. Okay, so 1 over secant of theta plus tangent of theta plus 1 over secant of theta minus tangent of theta. So a little bit different instruction. This one doesn't necessarily simplify down to something as condensed as what we've been doing. But if you can get that far, I'll show you where to go from there. Actually, getting in terms of the sine of theta is going to be kind of counterproductive. Let's just keep the same expression, see where you're at. Let's just simplify down to a single trig function. So maybe you'll backtrack. Maybe you already got there. You can backtrack and just erase. Or it could be a multiple of it. Did anyone get it? 2 cosine theta? 2 times cosine? Or 2 divided by cosine? Anyone else get something different but similar? But you got a cosine as well? Squared, cosine squared. Okay, so 2 cosine and a cosine squared. Let's see. Kiesling, what did you do first? Oh. Is that legal? It's not. No, in general, you cannot split up denominators like that. You can split up numerators. You can put every term in the numerator over the entire denominator, but you can't split up denominators like that. So that would be a wrong first step. So the way this will be graded on the test is if your first step is good, legitimate, then you're going to get a check, and the second check for finishing. You could, but you'd have to be careful. You can't just bring the secant to the top and call it a cosine and then say plus. Then you can't just bring a tangent to the top and call it cotangent. That doesn't work because they're 2 terms. But you could call it 1 over cosine plus 1 over cotangent, and then you've created a complex fraction, but that's going to be a little bit more challenging as well. Yes, Phipps? Final answer? Yes, Julia. What's that? Cosine of theta divided by 2? Tangent of theta divided by 2. No, not quite. The second term is 1 over 1. Well, secant theta minus tangent theta is only 1 if they are squared. So it's not a Pythagorean. Right, there's a lot of interesting things happening here. What could we do if we wanted to get 2 terms into 1? Yeah, but if you do that, you're not going to be able to say change flip because you have 2 terms. You're going to have to multiply by Lickum over Lickum. Get a common denominator. Combine them by getting a common denominator. Now, the common denominator is the product of those 2 things. So this one, you're going to multiply by secant of theta plus tangent over secant of theta plus tangent. And this one over here, you're going to multiply by secant of theta minus tangent all over secant of theta minus tangent. Now, when you do this, don't just have them floating out there like that. Always draw the line between them or you'll lose a point for notation. Okay, so now my common denominator is their product. Secant of theta plus tangent of theta times secant of theta minus tangent of theta. And in the numerator, I can just distribute. 1 times that is just itself, so secant minus tangent. And then this is a plus, so it's not as difficult. I'm just distributing a positive 1. So plus secant of theta plus tangent of theta. Had that been a minus sign right there in the middle, I would then need to distribute it to the secant plus tangent. So now that you've gotten a single term, you're well on your way to getting a single trig function. Anything good happen in the numerator? Well, the tangents at least cancel out. The secants double. So I get 2 secant of theta all over. Now, are these special products? Secant plus tangent, secant minus tangent. They kind of look like what you get. Conjugates. Yeah, they are. So when you multiply those out, you'll get a difference of 2 perfect squares. You'll get secant squared of theta minus tangent squared of theta, which now, Rebecca, because they are squared, is equal to what? 1. So you end up with 2 secant of theta divided by 1, which is just 2 secant of theta. Yeah. Well, it's good. I mean, everyone wants to call that 1, but they're not squared. So that's this one. That's a good one. Getting a common denominator really helps. Okay, that's probably the easiest first move. Now, Phipps, you mentioned something about putting in terms of sine and cosine. Remember, I told y'all the other day that that's your ultimate if you get stuck strategy to get unstuck. But look what that would look like. You'd have 1 over secant, which is really 1 over cosine, plus 1 over tangent, which is sine over cosine. So this would not be a wrong way to go. This one might be more scenic. Plus 1 over secant is 1 over cosine. Now it's going to be minus sine over cosine. Now what you can't do, you can't just put the cosine in the top and put minus cosine over sine. You can't flip both of them and bring them to the top. But you do have now a common denominator in the denominator, right? So if you don't want to multiply by LCM over LCM, you could do state change flip, but you'd have to do another step first. 1 over, and now you have 1 plus sine all over cosine, plus 1 over 1 minus sine all over cosine. And now because you have 1 divided by a fraction, a single fraction, not 2 terms, now you can do state change flip. So now it's just going to be cosine over 1 plus sine, 1 times the reciprocal, plus 1 times the reciprocal, you get this. So that's equivalent to what we started with. But guess what we're still going to have to do in order to get 2 terms into 1 term? We're still going to have to get a common denominator, which now, here's another way to get a common denominator. If you don't want to actually physically multiply by clever forms of 1, you could do the crisscross applesauce if you want. But you got to start in the top left. So cosine of theta times 1 minus sine of theta, and then plus, you take your middle sine, that diagonal, cosine times 1 plus sine, and then all of that's going to be over the product, which if you expand it out, because those are conjugates again, is 1 minus sine squared. This is another way to do it. This is a lot more scenic though. Now if you distribute the numerator, you get cosine minus cosine sine plus cosine plus cosine sine. And in the denominator, what's another name for 1 minus sine squared? Cosine squared. Yeah. And in the numerator, your cosines will double, and then your cosine sines cancel. So you're left with 2 cosine of theta all over cosine squared, which is really cosine times cosine. What happens with one of your cosines? Divide out, and you're left with 2 over cosine, which is also known as 2 times secant. Not sine. We get the same answer? Yeah, which way was more scenic? The one on the right. Which method was correct? Both. Right. So if you take an interesting step, you know, as long as you're not breaking any math rules, you're going to get there. You just got to keep at it. But here is the common mistake that students would make. They would go from there, and they would just say, oh, state change flip. So it becomes cosine plus cosine over sine. And that's wrong, because you have multiple terms. You can't just flip them both and bring them to the top. Yes, Tyler Allman. Maybe. No. If you wanted to put this one in terms of sine, I don't know why I asked that. I was thinking of a different problem. I wasn't imagining how this one turned out. So no, I wouldn't force that upon you. When we get to proofs, though, the right side of the equation gives you your target, and it might be in terms of sine. This one's not easy to put in terms of sine. It's easier to put in terms of cosine. Okay, so that was a good one to finish with right there. All right. Be working on the worksheet. Tons of good stuff on there. It's not due tomorrow. Tomorrow we're just going to continue with more of this. I think I'll have a handout for you, though, and we'll just work it in class. All right? I'll be here in the morning at 7 if you have any questions. Train for this test. Practice for this test. Be ready for this test, because the next one is going to be a lot more fun.